Good morning. Hope you guys are all doing well today. And we're going to do a Module 4 review. Let me turn off my music or pause it. I'm going to do a Module 4 review. Got my cup of coffee. We are ready to go today. Everything that we're going to need to know for the quiz tomorrow. The quiz will be on Canvas. We'll also be on Zoom, meaning you got to have your Zoom available in Canvas. So how it's going to work. We're going to have a Zoom invite that is sent, and there'll be one at 10 a.m., and then we'll send another Zoom invite. We'll just post it on Canvas for 1. And the Zoom length of time is going to be 1 hour, and that's the length of the quiz. Okay. So you'll have 10 to 11 or 1 to 2. The quiz is only supposed to be 30 minutes. That's what it is for everybody. But we're going to have, in case there are any accommodations for special ed for students, then we'll have an hour. But for the most part, everybody should be able to get done in the 30-minute window. All right? And so Zoom and on Canvas is how it will be distributed. Right now, it looks like it's going to be multiple choice. There might be 1 or 2 other types of questions on there. Okay, so all right, well, let's get into the content of the quiz. And one of the things that you need to make sure that you know how to do, of course, is you got to recall what a vertical angle, a linear pair, adjacent angles, all right, so let's take a look. You know, a vertical angle is just basically angles that are across from each other. So angle 1 and angle 2. These would be vertical angles. And we know that vertical angles are always congruent. Adjacent angles would be ones that are always next to each other. Okay, and so 1 and 3 would be adjacent. They are not necessarily congruent, but we know that they add up to be 180 degrees if they are considered a linear pair. Okay, so we understand, we should know those definitions. We also need to recall supplementary angles, some whose sum is 180 degrees, and complementary angles. Remember, if I get going too fast or anything on this video, just pause it, get caught up, and then you can keep going. So complementary is whose sum is 90 degrees. Okay. A linear pair and adjacent angles usually go together. Supplementary and a linear pair, they are closely related. Complementary angles usually are just adjacent angles, you know, something like this. Angle 3 and angle 4. This is 90 degrees because of the square. Sometimes it's a square like this. And if that's 90, then we know that all 4 sides are 90 because that'd be vertical. And then 90, and this is 180, so that would have to be 90. That would have to be 90. All the angles would be the same. Okay? So you need to make sure that you understand that terminology. All right, so let's see what else we got to talk about. Okay, so you need to know. Make sure I have enough room here. We need to know if we have 2 lines, and those lines happen to be parallel. Those lines are parallel, and they are marked by a transversal. And 8 different angles are created. We have 1, 2, 3, 4, 5, 6, 7, and 8. And though among those angles, we've got some relationships that are true. Okay, so one relationships are corresponding angles. Another relationship is same side interior angles. Another relationship of angles are alternate interior angles. We also then have alternate exterior angles. All right, so let's name in this what we know to be true. Let's see if I can use the red here. All right, corresponding means they're in the same position. So examples of corresponding would be 1 and 5. Angle 1 is congruent to angle 5. Because the lines are parallel, cut by a transversal, we know that corresponding angles are congruent. So 1 is congruent to 5. Angle 2 is congruent to angle 6. 2 and 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Okay? Same side interior angles, we know that they are supplementary. So angle 3 plus angle 6 is equal to 180. Angle 4 plus angle 5 is equal to 180. That's 4 and 5, 3 and 6. They're on the same side of the transversal. Remember, that's what this is called. Sometimes we label it T, called it transversal. And same side or supplementary. Remember the alliteration. SSS, same side supplementary. Okay. So far we've covered two types of angles. We've covered corresponding angles. We've covered same side interior angles. What about alternate interior angles? Okay, well, let's say 6 and 4. Well, if the lines are parallel, which we know they are, then we know that those are congruent. So angle 4 is congruent to angle 6. And angle 3 is congruent to angle 5. Okay, so 4 and 6 are congruent. 3 and 5 are congruent. What about alternate exterior? Well, they're on alternate sides of the transversal and exterior, so that would be 2 and 8. They happen to be congruent. They're always congruent. And angle 1 and angle 7. All right, so you need to know all of those. There won't be a proof on the test tomorrow. But you need to know all of those relationships for the quiz. Okay. Let's see what else we got here. Okay, that's good. All right, and really the two more topics that we could discuss as I'm looking at things that we need to review in the book. One is, remember that if it lies on the perpendicular bisector, so if this thing's a perpendicular bisector, if a point lies on this, so we know that this is true, then it is equidistant to the endpoints. Remember that? No matter where it is. So it could be here, and it's equidistant. It could be way down here, and it's equidistant. Okay, so if it lies in the perpendicular bisector, it's equidistant. And also, if it is equidistant, then it happens to be on the perpendicular bisector. So, perpendicular bisector. Another thing that we talked about was, well, we had y is equal to mx plus b, which is slope-intercept form. And then we had point-slope form, which is y minus y1 is equal to m times x minus x1. And that's called point-slope form. Well, there's one form that we've never really talked about. You have before, but let's just make sure we mention it. It's called standard form. Standard form of the equation looks like this: ax plus by equals c. Okay, and so you can solve for y, and if we did, we'd subtract ax. And so we'd have by is equal to negative 8ax plus c, and then divide by b. Separate the fraction. So y then is equal to negative a b x plus c over b. That's not all that important, but it just gets you into slope-intercept form. And so you could do that at any time. So if I have a standard form, let's say 3x plus 2y is equal to 8. And I wanted to look at that a little closer in a different format. I could solve for y. I could solve for y by subtracting 3x. 2y is equal to negative 3x plus 8. And then divide by 2. And then I have to separate the fraction over here. So y is equal to negative 3 halves x plus 4. So in that case, my slope is negative 3 halves, and my y-intercept is 4. Okay, so some people, they realize that you could do a shortcut, and when it's in standard form, you can find that the slope is negative a over b. That makes sense? And that the c value, which was this right here, in order to find the y-intercept, well, let's call that b value. You take the c value right here, which is 8, and you divide it by the b value. It's kind of a shortcut. But you don't have to do that. I mean, that's just if it gives it to you in standard form. If it gives it to you in standard form, you can always solve for y and do everything like that. All right, so back to here. So let's say that we have an equation. Let's say it's y is equal to 4x minus, let's say, 5. And we are going through a point, let's call it 3, 1. And we're parallel to this line, but we're going through this point. Okay? Parallel to this line, going through this point. So parallel means we have equal slope. So slope here is 4. So that means the slope of my new line is 4, but now it's going through this point. So I'm going to use these two things and plug them in to the point slope formula. All right, so here we go. Let's do it. So we go y, make sure you put the y in for y and the x in for x. Y minus 1, remember it's x, y, it's always in alphabetical order. So y minus 1 is equal to slope, which is 4, and then x minus 3. Now we distribute. To simplify, we have 4x minus 12, we still have y minus 1. I'm going to have to add 1 to both sides to get it into slope-intercept form, 4x. When I add 1, I end up with. So as you can see, these two lines have the same slope of 4, but different y-intercepts. This intercepts at 5, this intercepts at negative 5, and that intercepts at negative 11. Okay. One more. Now this one is, let's say it's perpendicular. So let's come up with a new problem. So we'll have, hey, let's use standard form on this one. So let's say we have 3x minus 2y is equal to, we'll say 5. And we go, it's perpendicular to that line, and it goes to the point 0, 3. All right, so if it's perpendicular to this line, what the first thing we have to do is we have to find the slope. Well, I showed you a shortcut, negative a over b. We could do that, or we could solve for y. Let's do it both ways. Okay, let's solve for y first, and then we'll do the shortcut. All right, so if I'm going to solve for y, I'm going to, let me rewrite it first. 2y equals 5. I'm going to subtract 3x from both sides, so now I have negative 2y is equal to negative 3x plus 5. There's some algebra here. Now I'm going to divide by negative 2. And so I have y is equal to negative and a negative is a positive 3 halves x. And then 5 over that would be negative 5 halves. Okay, so there's the equation in slope-intercept form. What's my slope? My slope is 3 halves. Okay, so it's positive 3 halves. So if that's the slope of the given line, that's the slope of the given line. What's the perpendicular slope? You remember how to do that? I hope you do, because you're going to need to know it for tomorrow. Remember, it is the opposite reciprocal. So if the slope is 3 halves, that means the perpendicular slope is negative 2/3. Okay, before we go and plug that into point slope form, let's first of all do the other way. So we solve for y, but what about the shortcut? Well, the shortcut told us that the slope is negative a over b. So if I have this standard form, and I want to go negative a over b, I just have to know what my a and my b is. My a is 3, and my b, negative 2. So negative a would be negative 3, b is negative 2, and we end up with 3 halves. Look at that. Let me get a marker to make it a bigger deal. So the slope is 3 halves, and the slope we found here was 3 halves. Okay, so we could use the shortcut, or we could solve for y. Whatever you want to do. I personally like the shortcut. Okay, so we got just a little bit more to do now. We know what the slope is. Slope is negative 2/3, and we know what point it goes through. It goes through 0, 3. It's perpendicular. Okay, now, one thing I didn't mention, does that mean that's the point of intersection between these 2 points? No, it does not. It's not necessarily the point of intersection. Okay? It just is a point that the new line intersects. Okay, so here we go. Where is, oh yes, point slope form. So we go y minus 3, and we go negative 2/3, and then x minus 0. Let's distribute the negative 2/3. So y minus 3 is equal to negative 2/3 x. What's anything times 0? 0. So we need to write it. Now we'll add 3 to both sides. Like terms doesn't have a variable with it, so we don't add it to 2/3. So we go negative 2/3 plus 3, and we are finished. Okay. All right, questions on that? All right, so let's finish up the idea of the quiz. All right, just to remind ourselves, we're gonna have a Zoom invite. It's gonna be sent to you in the morning. Okay, we're gonna start the quiz at 10. We're gonna have an hour to do it, so I'd be ready to go a little bit before. If you don't hit that one, then you got to hit the 1 o'clock one. Okay, got to have your computer because the actual quiz questions will be on Canvas. Okay, so you're going to be Zoom, so like I can observe you. So I can observe you, and then you're going to actually do and submit the questions right on Canvas. All right, so that's the plan. Any questions or any concerns, please let me know, and we'll see what we can do. I still don't know what's going on for next week. So whatever. Hey, be confident. I hope you guys have a great day. All right, take care.